Alright, so this is the final constructor response released in 2019. And once again, this is my very first time going through this one. Never looked at this one before. So you'll get to see my first reaction to this one as well. And how I, work through it for my first time doing it, right? And hopefully I actually don't have any negative feelings about this one, like some of the ones in the earlier ones from 2019. Here we go. What's this one about? Anne records the number of different colored beads in a package in the table shown below. Okay, so Anne, number of different colored beads. Okay, that's simple enough. Blue, brown, green, orange, red, and a yellow. Alrighty. Anne will randomly select a bead from the package, and then, without replacing it, okay, I know enough to know that that's a very important detail. Randomly select a second bead. Okay, so we select a bead, and then without replacing it, randomly select a second bead. Based on the information in the table, what is the probability Anne will first select a green bead and then an orange bead? Okay. Well, when you are doing multiple events that each have their own separate probability, this is important, okay? This is called compound probability. And you want to figure out the probability of these two or more events happening in a row or happening together. You have to, ready? Multiply the two separate probabilities together. So first we write down what was the probability of selecting a green bead on the first pick, on the first selection, okay? Now remember, probability is the number of favorable outcomes divided by the total number of outcomes. So there's 3 green beads possible out of a total of how many? Let's see, 5, that makes 9, then 12, 17, 21, 25. I'm going to go with 25. So 3 out of the 25 were green. So the number of favorable outcomes, which is 3, over the total, which is, let's just double check that. Let's go up this time. 8, 13, 16, and then 20, and okay, so we're going to go with 25. Times, okay, on the second pick, we have to get orange. Now, I'm already going to remind you that we are not replacing that first bead. So after I pick presumably a green bead, I have that green bead in my hand. I did not replace it. Okay? Now, there's still 5 orange beads to get, like 5 favorable. But now, the total number of beads, it's not 25 anymore. It's 24. Okay? So the probability of me getting an orange bead on the second pick is 5 out of 24. And like I said earlier, to figure out the overall probability, I just have to multiply these two separate fractions together. Now, the rest should be just academic here, but let me go into a little bit of detail, if I may, when it comes to actually multiplying these fractions together. I suppose you could just go to your calculator. Like, I imagine that, and there's like different ways to do this, you know what I mean? We could do like I don't even know what mode I'm in right now, but you could do like 3 divided by 25 in parentheses times 5 divided by 24 in parentheses. And so I imagine that if you wrote down this as a final answer, it would be okay. Like, it would be acceptable, okay? Maybe, what mode am I? Especially when you're in math print mode, you can actually, am I doing it wrong? N over D. You can actually enter these in as legit fractions. Again, you got to be in math print mode though. 3 over 25, and then hit the right arrow button, times, and then another N over D, 5, and then down, and then let's see what this says. Okay, 1 over 40. So again, knowing how to use a calculator, very, very, very useful. So I already kind of know that I could also write down 1 over 40 as my final answer. If I was doing this by hand, I hope you remember that, multiplying fractions together, you just multiply across, and you do like the numerator times the numerator, and then the denominator times the denominator. But, final answers need to be simplified. And so maybe you notice that you can actually simplify before you actually multiply the 3 and the 5 together and the 25 and the 24 together. You can actually do some simplifying here like this. The 25 and the 5 are going to reduce with each other. That would become just a 1, and the 25 would become a 5. So 5 over 25, that basically simplifies to 1 over 5. And then also the 3 over the 24, that pretty much reduces to that. So you can see now where, like, now that you multiply across, 1 times 1 is just 1, and then 5 times 8 is 40. So there's that final answer of 1 over 40. But again, did it mention anything about you need to give your answer as a fraction? Because I imagine a decimal, like you saw in the calculator earlier, would be fine. I don't see anything that says it needs to be a fraction. So I would imagine, what was it, like 0.025 or something like that? Like, I would imagine that'd be fine. Anne has a jar, so on to part B here, containing 375 colored beads. The beads in the jar have the same distribution, as the one shown in the table. Based on the information in the table, determine the number of red. Okay. Funny enough, this is kind of crazy. When it comes to like Keystone questions I've seen in the past, or heck, just like any random like example problem or something, like in any algebra book, textbook, like teaching about probability, the way this is worded, I tell you what, I've never, I don't think, like read a question that's worded this way. I'm like 99 to 100% sure I know what the deal is here, but at the same time, man, it's worth noting, I've never seen this wording have like the same distribution. That's interesting. So I guess I wanted to highlight that specific wording first of all, that there's, the beads in the jar have the same distribution. So what that means is like it's going to have the same like percentage, you know what I'm saying? That might be the best way to say it. The percentage of the beads in the jar are going to have the same percentages as the beads in a package, you know what I mean? So basically, the percentage of red beads up here needs to be like the same percentage in the jar, you know what I mean? So up here, it was basically the number of red beads was like a 4 out of 25 sort of like percentage or ratio or probability. And that needs to maintain the same sort of ratio when we're talking like in this jar of 375 total. So again, like 4 out of the 25 here, that same ratio, that same percentage, whatever, we need to figure out like what number out of 375 is going to maintain that. So that's what keeping the same distribution sort of means. And I wrote this proportion here. It's not the only way to figure this out, I guess, you know what I mean? But like you could figure out how many times 25 goes into 375, and that's how many times you're going to have like this 4. But I'm like literally going to do this cross multiplying thing. 25x equals 4 times 375, which my calculator tells me is 1,500. And now I would just be dividing both sides by 25 to solve for x. So 1,500 on my calculator divided by 25. So we're going with 60, you know. Another way you could have done this is like 4 out of 25. So if I literally do 4 divided by 25, that's 0.16, which is like, that means like 16% of all the beads needed to be red, you know. So 16% of the package was red. Likewise, 16% of the beads in the jar. So then you could do basically 0.16 times 375. And there, so there's another way, there's your 60. But anyway, moving to the back of the page, or the next page, the final page, where it's part C. Let's see what's next. Anne has some marbles. Oh, so she's got marbles and beads. She has some marbles in 5 bags. I don't like where this is going. Some information about the number of marbles in each of Anne's 5 bags is listed below. Okay. The fewest number of marbles in a bag is 21. Where are they going with this? The greatest number of marbles in a bag is 29. Okay, okay. The mean number of marbles in the bags is 27. Remember, mean is like average. It's literally the same as average. There are 2 modes for the number of marbles in a bag. Remember, mode means the number that occurs the most. And so it turns out that there is, 2 modes here. How many? So now, with all of those clues, we have to figure out, it looks like we have to figure out all the different numbers. Okay, okay. So I'm going to do some like scratch work. 1 bag, 2nd bag, 3rd bag, 4th bag, 5th bag. So from the clues, again, this is almost like clues to me. And you just have to utilize the fact that you know what the word mean means and what the word mode means to figure this out. But let's see, so that's got to be 21. That's got to be 29. And the mean has to be 27. And there are 2 modes. I wonder if there's one and only one way to complete these blanks. But, all right, so using the fact that the mean is 20, so what does that actually, what's that all about? Doesn't that mean that you would do like 21 plus, like let's call this X, Y, and Z right now. 21 plus X plus Y plus Z plus 29 all divided by 5, that's supposed to equal 27. All right, so 21 plus 29, that's going to be 50? And if I actually multiply that 5 to the other side, I believe I get 135. Again, doing mental math is a dangerous business sometimes. So you might want to do that on your calculator. But 5 times 27 should be 135. And then if I subtract 50 to both sides, and just for that, I will do that on my calculator just so I'm not a hypocrite. 135 minus 50. So if I minus 50 to both sides, I end up with x plus y plus z equals 85. Okay. So all I really know right now is that these mystery numbers have to add up to be 85. Because all this work I just did was basically because I knew that all of these numbers have to end up with a overall average of 27. So for that to be the case, for the mean of all the number of marbles to be 27, that means that all of these marbles have to add up to 85. How many marbles are in each of Anne's bags? Well, see, this is where I figure, like, is there more than one way to complete these blanks? You know what I mean? I wonder. Well, let's try something. What if my two modes were actually 21 and 29? Let's see if that actually works out. You know what I mean? Because again, x, y, and z can't just be anything. Like x couldn't be a 3, by the way, because again, 21 has to be the smallest and 29 has to be the largest. You know what I'm saying? So let's try this. Like, what if the two modes were actually 21 and 29? Okay, let's see if that actually works. If that was 21 and that was 29, that would actually make 21 and 29 also modes. So 21 and 29, that means like 85 minus 21 minus 29 would be 35. So if that was 21 and that was 29, it would make that one 35. That's not allowed to be 35. Oh, interesting. Oh my God, man. Are we just going to get into like super guessing and checking mode right now? Holy crap. Well, if 21 and 29 are not like both the modes, what if, one of them has to be a mode, right? It's not like you can have like x and y be a mode and then z would be like, no, like, so both of these are not the mode, but guess what? One of these has to be one of the modes, right? Let's go with that. So if it was 21, so it would be like 21 and 21, and then this would also have to be the mode, right? So let's say like this was 21. So 85 minus 21, that's 64. So if that was a 21, then these two together would have to be the same as each other, but also add up to 64. That would be 32. That's no good because that would make 29. Okay. This isn't as... But man, you got to be quite the detective here and the problem solver. So that means I'm pretty sure that I'm now locked in to this has to be 29. So this has to be one of our modes, and then whatever's here and here also has to be a mode. I think that's our only other option. Let's see. So 85 minus 29, so that means 56. So these two together have to be the other 56, and they have to be the same as each other. Oh, that was... And when you divide 56 by 2, it's got to be 28. So there we go, man. So that way, we end up with two modes, the 28 and the 29, and all three of these numbers add up to 85, which means that all five of these numbers will have a mean, an average of 27. But let's just triple check that, shall we? 21 plus 28 plus 28 plus 29 plus 29 is 135. All divided by 5, 27. Man, that makes me feel good to solve that, to crack that case. Whew. All right. Now, like, my closing thoughts on this is like, I actually enjoyed doing that because it was almost like playing detective and, I don't know, using like deductive reasoning or almost like a measure of your IQ maybe. I don't know. So it makes me feel good to figure that out. But at the same time, I'm not a fan of questions like this. You know what I mean? Like, I don't think you should feel bad for not being able to figure that out. I mean, because unless you did what I did, like, you would just have to do like insane guessing and checking. But again, like, as long as you understand what that word is all about and what this word is all about, you have a fighting chance to figure this out. But again, I like doing it, but I'm not a fan of making students, show their understanding of just these basic vocabulary words, like with problems like this. I think that was a little crazy, but I enjoyed it, and I hope you understand everything I did there. But anyway, that's it.